Hello and welcome everyone to part 4 of this tutorial. So just as a quick recap, our aim is to create this assembly and analyze it in Abaqus. What we've done thus far, we have created all the parts and created the assembly in the previous video. In this video we are going to looking to defining the analysis steps and also the contact the contact constraints and definitions. Okay, so let's get into it. Okay, so we already have all our instances and all lot, so now we want to create our analysis steps. Okay, so before as we should know by now, is before we can apply loads and boundary conditions, we need to create analysis steps so that we can pick in which steps which boundary conditions are applied. Okay, so to create our steps, if we go to the model tree, so our parts are there, our assembly is there, and then we go to the next big drop down, which is steps. We can double click on steps, which pops up with creates a new step. We're going to create the step contact, so we can define the contact between our parts, contact. And we can accept just static general and click continue. And then this pops up. And now in the description we can just say this step is to establish contact. And in incrementation, instead of using 1, we're going to change it to 0.1. I'm actually not quite sure what this means. That's just what I've learned. When you use contact problems, instead of 1 you replace initial to 0.1. Okay, so that's pretty much all we need to do in this step. And now our contact step is created. And now we're going to create our load step. So it's going to be initial step, which establishes the model, then we're going to establish contact, and then we have a load step that's going to apply our loads to this model. So we can say load, also static general. We're going to say continue, and basic we're going to say the steps apply load with 1L hopefully. And incrementation, again we just change it to 0.1. And we're going to click OK. Goof. So there's our 3 steps: initial, contact, and load steps. Next thing I just want to quickly speak about is we can, in Abaqus, we can specify what output we want. So we can request specific outputs out of each step or each analysis, which is quite useful. So the output is used to create deformed shape plots, and all the data that you're going to post-process if needed comes out of, well, the output that you request. So the default output Abaqus uses is stress, plastic constraints, translation, rotation, and concentrated forces and moments. But yeah, we can edit which outputs we want. So just to do that, to show you how to do it in this case, we can go to field output requests, and we can say manager, which opens our field output request manager dialog box. So with this we can define what requests we want. Just also as some background, the field output request manager is step dependent manager, so it depends on the steps. And the types of objects that appear in the step dependent managers are those that you can create, modify, and deactivate input in a particular analysis step. Okay, so what we want to do is from this manager we want to select if output 1, and we want to click edit, and you can see it is for the contact step. And now we can edit what outputs we want. So from the output frequency, okay, so we can edit the field output for the contact step. So the frequency is in what frequency we want the output to be recorded. We are only going to be interested in the last increment in this case. So now Abaqus is only going to record or generate the output for the last increment of the contact step. And that is pretty much all we want in this case. So we're going to say OK. Now that's the contact step. Now the load step is the propagated one. Okay, so now we go to our load step. We click edit. So the frequency on a load step, we want to record or generate output for every step in, or for every increment in this step. So we can have data for that. So we're going to select the frequency of every n increments, and we're going to click it every one increment. So each increment in the load step is going to have output. So now, from just to edit what output we want, we are going to expand contact, and for the purposes of this example, you can see all the output requests that are available. In our example, we are going to select CDisp, contact displacements, which is actually selected by default in this case, but it might not be. So we just want to make sure that we are going to get that output. So we can say click OK. And I think that is pretty much it, what we wanted to do for the load step or for the field output request managers. And I think you can see it says modified where it previously said propagated. So now we changed what we want to get out of the load step, and which is perfect. So we can just say dismiss, which closes the field output requests option. Okay, so the next step, we want to monitor certain degrees of freedom. So we are going to set up a degree of freedom monitor. So what we're going to do to define what degrees of freedom we want to monitor, in our case, we can create a node or set or node sets which can contain selected parts of a model. Once the set is created, we can use it to perform certain tasks, assign properties to it, create contact pairs, define loads and boundary conditions, and everything where Abaqus will prompt you for whether you would like to select a set, pretty much. Okay, so in this case, we are going to, in the model tree, expand our assembly, and you see there is the option for sets. So we're going to create a set. Then this option appears, and instead of set 1, we are going to name it monitor. And geometry is the only type we have in this case. And then Abaqus will select the geometry for the set. So it asks us what do we want to have included in the set. Okay, so what we want to monitor is the solid hinge piece. We want to monitor that corner over there of the solid hinge piece. Just make sure Abaqus highlights the right thing. So we click that node is what we want to monitor. In this case, I think that is the only thing in this set. And let's click done. So that's gonna remember that we selected that node, and the set would be the monitor. So if you select the monitor, that node we just selected is also colored red, so we can see it. Okay, now what we want to do, we want to go to output. So step, we're going to double click on steps, sorry. And then from double click on steps, we get the step main menu. So for example, if we go to models, cancel, it creates, the parts option. We are gonna go to steps, and you see double click on steps, just cancel, creating a new step, and now we can see that menu. So we're gonna go to output and say DOF monitor or degree of freedom monitor. I want to model the degree of freedom throughout the analysis, and it asks us for a region, degree of freedom, and print message file every 1 increments or whatever. So what we're going to do is I'm going to select, and then we're going to click points, and then we can select monitor, which is the set we created, and then we can click continue, which brings us back. So monitor region is selected. The degree of freedom we want to select is degree of freedom 1. I want to keep the default as print to the message file every 1 second, and click OK. So now the monitor has been set up. Okay, so the next step we want to do is we want to create surfaces to use in our contact interactions. So now is the interesting part in Abaqus. Okay, so to define contact between regions, there are two approaches that can be adopted. The first is a manual approach that's required you to identify which surfaces will actually touch and then tell Abaqus those are going to be the touching surface. Or alternatively, Abaqus can automatically do that. So the automatic approach is, well, desirable because sometimes it's difficult actually to predict what is going to be in contact and what not, and if you miss one or two things that's going to come in contact and it's not defined as such, your analysis results may be wrong. So yeah, that's just something to keep in mind. So also just note the automatic contact definition option is available only for 3-dimensional models. So for 2D models you would need to do it manually. So if you're going to do it manually, you need to define surfaces. Okay, so when manually defining contact interaction, the first step is to create the surfaces that you will include later in interactions. It's not always necessary to create your surfaces in advance. If the model is simple or the surfaces is easy to select, then you can just click on them when you click on the master and slave surface directly in the viewport when you create your interactions. So in this case, to just show you how to create surfaces, this is what we are going to do. Okay, so we're going to make I think about six surfaces, I think. So the first surface we want to define is the surface of the pin, because it's obvious the pin is going to be in contact with everything else. And then the other surfaces are going to be the flange, the two flanges that are going to be contact with each other, where they're going to touch there, and then of the two hinges, and then both of the inner surfaces of the hinges that are going to interact with the pin. So that's the pin surface 1, 2, 3, 4, 5 5 surfaces we are going to define. Okay, so the first one, we're going to define the surface on the pin. So the easiest way to do that is we're going to essentially filter our view to just look at the pin. So from the main menu bar, we can go to View and Assembly Display Options, and select in the Instance tab, we can click what instances should be visible. So in this case, we're going to turn the other two nice and off and say Apply, and it only shows our pin, which is brilliant. Okay, now we need to define the surface of the pin. In the model tree, we go to Assembly, there's Assembly, and we can double click on, you guessed it, Surfaces, and this pops up. So we're going to call our surface pin. I'm going to click Continue, and we can select the pin. Well, we can say individually, select our pin, and that's pretty much it. Okay, now you'll notice this thing is, well, multicolored. Now Abaqus asks us choose a side for the shell or internal faces. So each side of the hollow cylinder represents the pin as different color. In this case, our outside is purple and our inside is this brownish color. You can see there, if you look inside it's brown, outside it's purple. That's how it currently is. And the way it picks which is inside or outside by default is which way you drew the line for this pin. So now we must select which surface consists of the inside or the outside of the cylinder. In our case, the outside surface contacts with the two hinges is the desired choice. So we want drag them out. So choose the side for the shell or internal facer. The side would be the outside. So our outside is purple. And then that's it. Now our pin is created. So now we want to define our surfaces on the hinge pieces. So again, just to filter our view, we go to instances, we turn the pin off, and we select the hinge with hole. Voila, which is quite nice. So now again, we go to surfaces, double click surfaces, and we're going to name this flange hole, which is the flange of the hinge with hole. That's quite a bit of a tongue twister. And so now I want to select the flange which is going to touch with the other hinge. So just to finish my rotation, I want to select that flange, and we can click done. And then our surface is created, flange H. That's brilliant. Now we want to create another surface for where the pin is going to interact. So we're going to call that inside H. And now we want to select the inside surface of the hole and say done. And you can say, see, inside H is there, flange H is there, and the pin we can't see. Okay, so now we do the same thing for the other instance. Go to view, assembly display options, hinge solid 1, and we just rotate so we can see what we want to select. Whoops. Hey, there we go. Now I can sort of select all the things I want to select. So now we create our surfaces again, double click on surfaces. I'm going to call this one flange S, which is the flange. I'm going to select the flange, click OK or done. I'm going to call this thing inside solid. I'm going to select the inside of the member and we click done. Okay, so now that our surfaces are defined, we can continue to defining the contact between regions of the model. Okay, so interactions are objects that you create to model mechanical relationships between surfaces that are in contact or closely spaced. So yeah, just because things are close to each other in an analysis or a model is not enough so that Abaqus actually knows it's not enough to indicate that any type of interaction exists between two surfaces. So it's better to define them physically. Okay, so in this case we will define two interactions between, well, the pin and the holes of the two hinges and the two hinges themselves. Okay, so each interaction requires a reference to an interaction property. Interaction properties are collections of information that helps us define certain types of interactions. Okay, so in our case we will create mechanical interactions that describes the tangential or normal behavior between all surfaces, and we will assume the surfaces are frictionless. Okay, so let's get into it now that we have some background as to what this actually is. Okay, so now if we want to create an interaction property, so we can double click on interaction properties, and we will call this one no friction, no friction, and it is a contact type, and we can click continue. And next, the edit contact type property box pops up. We can go mechanical, tangential behavior, and we assume it's frictionless. There are penalty, rough, Lagrange multiplier, or other options. In this case, we are just going to stick with frictionless. And that's it for this property. So now our interaction property is made, and it sits under interaction properties, as you can see over there. Doof. Okay, so now that our interaction property is created with specifying no friction, we move to defining interactions. As I've said in the beginning, there are two ways to do it. You can either create them automatically or manually. So I'm going to show you both ways just for the sake of completion. But yeah, and then I'm going to also suppress the ones we're not going to use. Okay, so I'm going to turn all our instances on. So you double click on assembly, so it gives us the assembly menu. So you can go to view, assembly display options. Sorry, missed the click there. Instance, I want to have everything visible. Voila, there's all our things. Okay, so again, just to show you how to define them automatically, we go to interaction. No, not there. Interaction. This pops up. I'm not interested in this yet. So we go to interaction, find contact pairs, and then this pops up. So now you can select the domain as the whole model, include pairs separate tolerances. You can keep that as default. Then we can click find contact pairs, which should identify the pairs automatically. And now I'm going to try and make this a bit bigger so we can actually see what's going on. Okay, so now it identified 5 contact pairs by itself. So now what we're going to do, we can click this pair, then it shows us where the contact is. So it's, well, then it highlights what all the pairs that are identified. You can see this is the hinge and that face, the face between the two hinges, the hinge and the pin, oh no, sorry, the hinge and that square face of the opposite hinge, the pin and the inside of the one hinge, and the pin and the inside of the other hinge. Okay, so that's what Abaqus identified automatic. So we are not really interested in the contact between the hinge, the two hinges and that face over there. So if we want to or we don't want to have them, we can select them and either say delete contact pair, or we can just right click on them and say delete. So that pair is gone. Its twin brother we want to delete as well, so you can just click delete. So the only 3 contact pairs that are left are that one, the pin and the one hole, and the pin and the other hole. Okay, just to so I know what contact pairs are, you can rename them as well. So we're going to rename this one as the hinge with the hole. So we just name this hinge pin hole, and the other one is going to be hinge pin of the solid hinge, and the last one, which is the 2 flanges, I'm just going to call them flanges. You also get the option to switch master and slave surfaces. So what that does is contact, it identifies one face as the master and the other one as the slave. So as the one deforms, the other one deforms as well. And that's pretty much it. So if you want to view master and slave names instance names to aid the surface designation, we can say edit visible columns, and then we can tick master slave name or master slave and tick that on, and it shows us, well, just color codes, and it shows us the name of that planes as well. So you can see it says slave instance, master instance. It shows us which instance is the master and which instance is the slave. Okay, that's pretty much what we need to do, and we're going to keep the defaults as they are, and we're just going to go to discretization, and we're going to click node to surface instead of surface to surface. So a nifty way to select all of them, you can right click on the heading and we can say edit cells, and then we can, instead of surface to surface, we can say node to surface and click OK. And this is pretty much all we need for contact pairs. So you can click OK, and then you can see we have 3 interactions defined. And as you cycle through them, Abaqus also highlights it for us in the viewport. Okay, so that's pretty much all you need to know for doing it automatically. Now I'm going to show you how to do them manually. Okay, so now you can go to interaction and go to manager, and then this pops up and it shows you there's our 3 that we created automatically already, but now we're going to do them manually. So we can click create, then we can name it. So we can say let's call them M, so we know which one is manual. The manual hinge pin hole, and the step we want to establish the contact in the, or the interaction in the initial step. In the types of selected step we can click, well, there's different options. We are going to use surface to surface as the default option, and we're going to click continue. Then it asks us select region, so we are busy editing which one was it? The hinge pin with the hole. So I think we just click highlight so we can see what we are actually dealing with. So we can move this out of the way so we can just see on a model. So we want the hinge pin with the hole, so the one with the hole in it, and the pin, so we want the pin and the hinge with the hole. So that's the two what we want. So yeah, now Abaqus asks us to select the master surface from the dialog, so we can just, the master one would be the pin in this case. So there are the sets that we created earlier, that are the automatic ones. So we're going to click, the pin is going to be our master. I'm going to click continue, then Abaqus asks choose the slave type, and we're going to select the surface, and it's going to be inside hole. And then edit interaction pops up after we click continue. So it's manual, hinge pin hole, surface to surface contact. So what I want to do is we're going to accept the default sliding information, default finite sliding, discretization method. We want to use node to surface, which is the one we have in our automatic one as well. So in slave node adjustment we want to select no adjustment, and we can say no friction is the contact. And we can click OK. Oh, sorry, my bad. It's going to be surface to surface. And we say okay, so that's the manual hinge pin. So we go again, create. We're going to call this one surface to surface is fine. Initial step, so it's going to be manual hinge pin solid. Initial step, surface to surface. Click continue. The master is again the pin. I'm going to select the surface, and the next one is inside solid. Click continue, and we're going to save that. That's the same, and no adjustment. And we're going to also say no friction is a property. And again, we can click the master slave surfaces to be switched if you wanted to. Now for the two flanges we create, you just call them M flanges, initial wada. So you're gonna pick flange H first and click surface, and then it's flange S, and we click continue, and we can switch them around. You can see Abaqus switches the master and slaves. In our example, it doesn't really matter which one, but let's use flange H as master surface, so we have the same thing and no friction, and that's pretty much it. And now all our interactions are defined. We can click dismiss. Okay, one thing to note is we have 6 interactions, whereas we only really need 3 because we have duplicates now. But one thing that is interesting is, yeah, we have duplicates. So I'm going to just remove the ones with the M. Instead of deleting it, I'm going to suppress it. So it is still there, it's just not activated in the model, which is actually quite useful. So for example, we can redo the analysis by just, well, suppressing the automatic ones and clicking resume, and then it's activated again. Yeah, so as I said, for different loads and different conditions, it's easier, instead of having different models with the same, well, the same model with different loading conditions, you can just have different loads on and off, or have them in different load cases or things like that. Okay, so now our steps are created and our interactions are defined. It's a good place to save in case anything goes wrong. And yeah, that's it for this tutorial. Thank you very much for watching. In the next tutorial, we are going to create boundary conditions for the assembly, and also create a job and apply loads and see what Abaqus gives us as a result. Yeah, thank you very much for watching this part of the tutorial, and please watch the next one. I will link it in the description. Thanks again, and have a lovely day.